Good morning, children. Today we are going to discuss the question and answers, the detailed question answers for all the lessons which we have taken. Okay, you need not write them in your class or notebook, but learn one by one, and you can write it in your homework notebook or rough notebook and see. Okay, the first question is explain the arrangement of molecules in solids and liquids. So we'll be talking about the molecules, how the molecules are packed, then the intermolecular distance, then the intermolecular force, and then our shape. Okay, so what happens? The molecules are closely packed in solids, they are less closely packed in liquids, and they are more loosely packed in gases. Then the intermolecular distance is less in solids, it is more in liquids, then it is large in gases. Force, what about the intermolecular force? It is very strong in solids, it is weak in liquids, then it is very weak in gases. So this makes the molecules move freely. Then it in the molecules cannot move freely, whereas in the liquids they can move around easily, and in gases they are very free to move anywhere. So the fixed shape is obtained here, as the liquids can flow, whereas gases can diffuse. The keywords are very important. Here the flow, here it is diffuse. Okay, coming to the second question, summarize the properties of solids, liquids and gases. Okay, we are going to summarize. How are we going to summarize? We are going to start from the arrangement of we'll write the properties in the side and then we'll compare it. First one is the arrangement of molecules, second one is the intermolecular distance, then the third one is the intermolecular force, the fourth one is the shape, fifth one is the volume, sixth one is the compressibility, then the ability to flow, and the diffusion. Okay, accordingly we have put this tabular column. If you write like this will be enough. Coming to the lesson 2, we are going to first see the first question, which is distinguish between the reversible and irreversible changes. First one, reversible and the irreversible. First write the definition. Reversible, that changes can be reversed. Irreversible, the changes that cannot be reversed. Then can get back the original substance. Here we cannot get back the original substance. Here no new substance is formed. Here new substances are formed. The properties do not change. Here the properties change, and the change is temporary. Here the change is permanent. You have 5 to 6 examples for reversible and irreversible. Okay, now a change can be desirable at one point of time and undesirable at another. Why? We can say it is based on the situation when it is occurring, the change. Rain is desirable because it is the main source of water, but if the rain occurs in excess and causes flood, it results in loss of property and life, so it becomes undesirable. Then cutting down the trees for industries is desirable, and excess cutting of trees will cause pollution. Similarly, burning of the fossil fuels will give us lot of energy, which is very required, but when it causes pollution, it becomes undesirable. Now coming to the differences between physical and chemical changes. The changes in which no new substances are formed will become physical. When new substances are formed, it will become chemical. Now the physical properties will change. The physical properties also changes along with the chemical properties. Okay, in physical change, chemical properties do not change. Here the changes are temporary and reversible. Here the changes are permanent and irreversible. And less amount of energy is absorbed or released, whereas large amount of energy is absorbed or released. Okay, now coming to the fourth question, explain evaporation as a physical change. What's to give the definition for evaporation? What is evaporation? Evaporation is a process in which a liquid gets converted into its vapor on heating. Okay, now coming to the water molecules have the same chemical properties. Okay, they have the same chemical properties in both liquid and gaseous state. So only the state has been changed and no new substance is formed. So evaporation is a physical change. Okay, now coming to the next question, rusting of iron. What do you mean by rusting of iron? The process in which the iron objects form a reddish brown or a flaky substance on their surface when they contact moisture or the oxygen present in the air is known as rusting. Then what is called rust? Here the rust is a new substance. We cannot get back iron from the rust. So the change is irreversible and hence the rusting of iron is a chemical change. Curdling of milk. What is that? The curdling of milk is a process in which the milk is converted to curd with the help of a bacteria. Now this bacteria converts the lactose present in the milk to the lactic acid. Now the lactic acid gives the sour taste to the curd. Chemical properties of the curd are different from that of the milk because curd is different, totally different from the milk. So also the change is irreversible. We cannot get milk back again from the curd. So this is a chemical change. Now you have to explain the concept of energy changes for both physical and chemical with an example. Okay, so first one, characteristics. The energy change is minimal for physical change. Only the change of state occurs. Okay, then example, the ice absorbs heat upon uh, melting. This energy is required to increase or decrease the intermolecular force between the molecules. So the energy which it is absorbed is used to increase or decrease the intermolecular force. So ice absorbs the heat energy upon melting. Water releases heat energy upon freezing. Now coming to the energy changes in a chemical change. Energy change is more, totally new products are formed. The properties are totally changed. Example, burning of fuels. Now coming to the lesson 3, we need not learn the first question. We are going to the second question directly. Okay, write the features of the modern method of representing elements. How are we going to represent the elements? Okay, the features, the first one is we are taking the first letter of the name of the element as symbol. Okay, now it is written in the capital letter, that is O for oxygen, H for hydrogen. Now when two elements have their names starting with the same English alphabets, then we use a two-letter symbol. The first letter is the letter from the name of the element, and the next letter would be the non-repeating letter of the same element. Okay, say example, calcium. We are using Ca. Okay, then Cd for cadmium, then Cl for chlorine, then CO for cobalt. Then this is the second situation. Sometimes we will be using the Latin names. Latin names, the names given in the Latin language. From there we can take the symbol. Okay, the Latin name of potassium is Kalium. So the symbol is K. Similarly, the Latin name of gold is Aurum. So the symbol is AU. Now we are going to see the third question. What are the steps involved in writing the chemical formula for magnesium chloride? First, we have to write the symbols. For magnesium, it is Mg. For chlorine, it is Cl. Then we go for the valencies. For magnesium, it is 2 and 1 for chlorine. We have to write it on the top. Then we are going to interchange the valencies by writing it like this. Then the final formula, we can write it as MgCl2. Okay. Now, this type of questions are easy to score marks. Okay. So you can concentrate more on this type of questions. Now, for the following chemical compounds, you have to list the number of atoms. So, chemical formula they have given. You have to write the compound name. Okay. Then the constituent elements and the number of atoms. Calcium, CaCO3. CaCO3 is nothing but the calcium carbonate. So what are the constituent elements we have? Calcium, carbon, oxygen. One atom of calcium, one atom of carbon, 3 atoms of oxygen. Similarly, KNO3, it is known as potassium nitrate. How many elements are there? Potassium, nitrogen, oxygen. So potassium 1, nitrogen 1, oxygen you have 3 atoms. Coming to H2SO4, it is a sulfuric acid. Here we have hydrogen, sulfur and oxygen. Hydrogen 2 atoms, sulfur 1 atom, oxygen we have 4 atoms. Then the sodium hydroxide. Here sodium Na, oxygen is and hydrogen. All are having 1 atom each. Okay. Now coming to the fifth question, you have to explain the method of distillation. You have the diagram. You have to take the diagram from page number 38. This is a separation method to separate a pure liquid from a mixture by evaporation and then by condensation. We are going to use a special apparatus. What are the apparatus and what is the 3 steps? The first step is the mixture is heated in the round bottom flask. Then the liquid will evaporate. Okay, the solid is left behind. Now the evaporated vapors, the vapors after evaporation are condensed with the help of the condenser. When it is condensed, it will form a pure liquid. Then this pure liquid is collected separately. Example, the distilled water is obtained by this method. Okay, you need not write all the things given in the book. Okay, that is why I have cut short and I have written only the necessary points for the explanation. Okay, so learn only this, refer the book for diagram or any other things, but for exam if you write like this is enough. Okay, so now coming to the fractional distillation, refer the diagram in the page number 39. Now start writing the principle first. Okay, the principle, that is the definition. We are going to separate the mixture based on the differences in the boiling points. Okay, the liquids will be boiling at different temperatures. Accordingly, we are going to use the principle here. The apparatus will have the distillation flask, fractionating column, condenser. That is how we are going to do is the procedure. In the procedure, we will be writing When the mixture is heated in the distillation flask, it boils, vapors arise, and as the vapors go up in the column, the temperature will decrease. And then we are catching up it in the condenser. Condenser, the vapors cool down, will condense to form the liquid. So the evaporated liquid is caught in the condenser. The condenser will be collecting the liquid later. So one liquid will be retained in the distillation flask itself, whereas the other one will be collected in the condenser. Now the liquid with the lower boiling point will vaporize first, okay, and it gets converted to liquid. Where are we using this? To get the petroleum products. So understand this and then write the answer with the diagram. Okay. In the G question, explain how we are going to use a separating funnel for separating immiscible liquids. Now first you should draw the diagram, then say separating funnel is based upon the principle that lighter liquid floats whereas the heavier liquid is below. Now the apparatus, you have a special separating funnel with a narrow bottom with a stopcock. Now we are going to pour the liquid into the mixture into the funnel and then leave it undisturbed, don't disturb. Then it will form the two layers, the immiscible liquid will form two layers. Once the layer is formed, we can open the stopcock. So the heavier liquid which is at the bottom will flow first and it is collected separately in a container, whereas the heavier liquid is retained in the separating funnel itself. Thus, the two liquids are separated. Then the mixture of oil and liquid can be separated by this method. Okay. Now, children, refer this for your learning purpose. Keep your textbook nearby, then learn. Write it down, all the heavy spellings, oxygen, hydrogen, every spelling, write it down. Then only you can write the answers without spelling mistakes. Okay, learn this and you can write this only for the examination. Don't write it in the classwork notebook. This is only for your learning purpose. Okay, thank you.